Welcome everyone to ModX Virtual Exchange. Today we have a guest, one of our ModX network voices, Todd Beyreuther. Todd is an adjunct research professor at Washington State University. He just recently left Katerra as a senior engineer in their mass timber operation, and he has started a company called Mass Timber Systems. He'll be talking about his journey and his story, and we want to thank Todd for coming. Welcome, Todd.
Greetings. Thank you for having me.
Of course, we're also joined by Ivan Rupnik. Ivan, you want to say hello?
Hi, everybody. Hi, Todd.
Greetings, Ivan.
Well, to start off, we thought, Todd, you could just tell us a little bit about your background and your progression. Been over a decade you've been working on mass timber, and you're quite a leader in this space. And Todd has been really great to go with us on a lot of our adventures throughout the world, to Japan, and he's been on our Northeast and Northwest adventure, and hopefully will be joining us in Sweden later this year. So Todd, you can give us a little bit about your progression through mass timber, and then we'll have a discussion about some items. Todd will be sharing his screen periodically throughout the presentation.
Yeah, that's great, and thank you. And I want to really thank both you and Ivan for your leadership in this area, and for this impressive network you've built. And it's been an honor to kind of come along for this journey. And ironically, Ryan, I think we probably first met about 10 years ago on a bus in Miami at an academic conference.
That's right.
And I can be more happy and proud that you're now our paths have crossed again, at Washington State University. So, yeah, I think what I'd love to do is share a little bit about this. I am in transition right now, and very energized by it. Maybe a little bit briefly about myself, and I put a little outline up here to share that is as much about a journey, and maybe this is the beginning of kind of a third act, and I mean that as a collective journey, because yes, it's personal, but also this effort, mass timber in general is both obviously a global, but also a very local, regional effort that has been very focused, very coordinated, I would say, for about the last 6 to 8 years, especially in the state of Washington and the Pacific Northwest. So I put these up as phases. These are really, different kind of evolutions of where we're going. And this last development phase, which I think we'll get into a little bit later, is now where I'm most excited now to get into this assembly and kind of modular level, design of capitalizing on many of the assets that we've been able to put in place. And those assets just aren't the economic and physical assets of production and factory and so forth, but it's all of that social capital that we've had to establish, the political capital, meaning actual policy and codes and so forth, that momentum that we need to allow us to do this. And then that also is very important. I think people might know I lecture and have focused a lot of my research and development on bioregional scale efforts. We're talking about timber, and that's a natural asset that we need to capitalize, not just in terms of economic capitalization, but in order to do positive things environmentally and in terms of our rural economies and so forth. So maybe what I was going to do is briefly kind of step back about 10 years ago, literally. Mm-hmm. About 2011, I started professional practice in structural engineering and architecture. Those are also my academic degrees. And as I started to move into design research, first at University of Washington and then at Washington State University, in about 2011, 2013, we started to coordinate research around large supply chains, around large bioregional problems. And so one of them that really was an origin story for us at Washington State University was analyzing both the environmental and what we call the techno-economic aspects of a mass timber supply chain. We were already working in areas of biofuels, and my role was to look at, a co-product of biofuels, meaning made from forest residuals, and that was the first and best use of the saw log. So what new markets can we create out of what typically would be thought of as just as lumber, but moving into lamp stock and engineered wood products. So my affiliation at WSU is with the Composite Materials Engineering Center, and they have a long history of developing engineered wood products, whether they're strand-based, veneer-based, or in this case, from actual sawn timber. So anyway, we don't have to study this, but the goal was to go out and analyze different types of supply chains, ending up with actual buildings. And in this, we really isolated down, and I think I revisited this recently, that was in 2015, and we really came down to two models that we collectively proposed, and now we can say in 2020, reflecting back, is we've achieved in this region. So quickly looking at this diagram on the top, the baseline, the European model, and as CLT in particular, and I'll focus on CLT today, the model was that you would build a CLT factory, and maybe a modest size one, and you would buy lumber from a mill. So you have the harvesting piece, the milling piece, and then this manufacturing. So there's this pressing of the panels and this subtractive, milling, and then we would move that straight to the job site typically, and that's still the typical model in North America. And now we're starting to see the second line evolve, where you have a mill, maybe traditionally a family mill like Vaughan Brothers or Kolesnikov or others, and then they co-locate CLT or glulam manufacturing, at a right size to that mill. So those will be smaller facilities, and it's very important that these exist to have value add for those mills to create this more robust supply chain, not just for lumber, but for what I term lamp stock. And the difference there is lumber is a commodity product used for studs and joists and so forth, and lamp stock is specific. It's still a rectangle, but it's specific to engineered wood product. And then the third one, which I call supply chain 2 here, was what if you came in and vertically integrated? And we thought this was a little bit more of a stretch, but as we know now, we see factories like Katerra, and that's how I evolved and was asked to join that team to propose and help advance, that enterprise. So we do see now this larger scale factory, and there are about 2 or 3 other, I call them second generation factories coming online in Europe that are about that same level of technology and scale. That could also have the ability to do more advanced additive manufacturing and systems integration, although I would argue we haven't seen that yet. We haven't seen that co-located with that pressing and that manufacturing. So stepping out of it now and looking back, that's really this bottom line now. And I think if, in 2020, this is going to be, my focus for the next 10 years is to develop this kind of red-orange piece here, and this is really the overlap with the ModX, where you have those 2 right-sized supply chains for mass timber, CLT, glulam, Dow, whatever it might be, but they're thought more of as advanced contract manufacturing for the specific goal of doing off-site assembly level and modular level mass timber components. So quickly going through, I just want to flash some of the images of how we conceived of this, 5 or 10 years ago.
Hey, Todd, real quick on that. Why don't you go back a slide real quick?
Yeah.
It's an interesting conversation Ivan and I recently had about this exact thing that you're outlining, which is one of the first steps in supply chain optimization for any product would be to integrate the entire supply chain under one sort of organization, whether it's a company. So in the case of Katerra, right? And that could be very effective. but even Katerra has said, and others in the space of vertical integration, that ultimately the goal is to not necessarily own the entire supply chain, but develop a supply chain capability that could help to increase capacity and capability. So for instance, in the case of Apple, they built a lot of their own capacity for manufacturing, but then realized that they really needed 3 separate suppliers that could supply into their supply chain in order to deliver on the iPhone, for example. And I know we're not talking about an iPhone in this case, but I think that curve in
Similar principles.
Technological integration is that you see vertically integrated companies, and as that industry matures, whether we see the offsite and in particular mass timber solution mature, those companies start to desegregate and disintegrate after a while to provide value added along that supply chain. And I think that's kind of what you're showing here, is ultimately you could have multiple suppliers like a Vaughan or other factory supply into that additive manufacturing and systems integration, but that might be done by a third party and not necessarily those CLT manufacturers themselves, right?
I think it's a great point, and as I have evolved over along this journey, I've realized that it's as much about this standardization, between the different partners, so that we don't get into this very proprietary mindset. In fact, we did some work a few years ago, and we being University of Washington, Indra Neil Ganguly, who's with Centrifor, really a trade-focused and market-focused group in forest products, and the goal there was to develop market diffusion models that looked at these, CLT in particular, and how do we accelerate that? And what are the key drivers? And the obvious ones were, of course, we have to have code and jurisdiction acceptance, and we have to have education of architects and engineers, and then the third major driver, the obvious one, has to be competitive. If it's not cost competitive, then we're really creating a niche product, and that's going to hit the brakes on that market diffusion. But in that, we started to pick apart that one of the challenges, especially as it relates to cost, is assumptions very early on in the supply chain. In Europe, a mill might make 90 different SKUs, 90 different products that go out of there, and they go to furniture and go to so forth. So they're very open and used to developing different sizes, different grades, and so forth. Whereas in North America, we found that one of the biggest limitations in this is we start with, it shall be a 2x6. That is a product for a different market, and we really have to overcome that and create a new standardization. And that's been one of the biggest challenges. But I think as we move forward, and I would say that the vertical integration didn't necessarily take care of that. I think if it's going to be this focus on design and product development, and I hope in this orange box here, more in that in between of the big dumb panel, I like to say, and the eventual assembly on the site.
Yep.
So maybe showing a few more images on some of the previous research, and some of this was sponsored by USDA. Of course, as we scale jump, we're talking about the assemblies and the near human environments. We get to the system scale, and that's where we start to have interesting discussions about whether or not you are creating these certified, parametric systems that can be utilized without limiting the creative space in terms of architecture and engineering of whole building systems. So what is that appropriate balance between a certified assembly or an optimized assembly in manufacturing and still enable that creative freedom? And I know this is where I'm really interested in the modular world, where often we set those constraints early on. It shall be 14 by 65, right? Feet, right? To go down the road.
Yep.
You know, and then what we won't talk about so much today is you know, a lot of our focus on both urban scale, on districts, on planning, so forth, as we get into the, you know, some of the new codes for mass timber, but then also that political level at the states and the bioregional level when we get into more of the environmental impacts and so forth. So lots of glue and wood back at WSU, you know, the material scale, the assembly scale, a lot of seismic work that's done on NSF projects. You know, it was really a great time to be there in the early, you know, like 2010 to 14, so that we can get back to this building scale and this decoupling of that assembly and system and whole building design. And that's not just structural, of course. It's energy, it's carbon, and understanding, you know, the opportunity with mass timber, and the way that I always taught mass timber to architecture engineering students was, you know, the first day of architecture school, at least for me, you know, I was given a bunch of cardboard and an X-Acto knife. And that's how we started to explore, you know, space through that scale, which is really an assembly scale, right? We weren't given a bunch of sticks and say, you know, put studs and top plates and so forth together. It's look at these planar elements and create volumes and explore, you know, what you think that experience could be. So I really think when people ask why is mass timber attractive, especially in architecture, I think a lot of it comes back to that ability to really deal with those planar elements. And then getting into some of the more robust plug and play ideas that eventually get into, and I'm showing student work here purposely. This is from 5 or 6 years ago at WSU. We have this little army now of mass timber parametric, you know, architects and engineers out there. It's been great to watch them, you know, grow in their careers. But really, these ideas that these elements are ideal for parametric modeling. We can create a certain level of standardization with these, you know, these piers, these walls, these diaphragms, but still have a lot of flexibility in how stresses and forces and stiffness moves through that building. So really that's kind of the basis for where, you know, I am right now with these, you know, creating this glorified catalog of parts that can be used, you know, straight out of you know, when I say catalog, that's of course digital and you know, focus on all the different metrics, you know,
right.
the metadata that carries throughout that supply chain. But so that's really where my head is these days.
Yeah,
that's an important maybe distinction. I just wanted to add, Todd. It's really exciting stuff. But the idea, we talk a lot about design for manufacture, but the idea that you're developing, or you're in the position that you've been able to develop designing manufacture for design, or thinking about how to develop systems around how designers will use those systems. And that's something, if you go back a few slides, I mean, it's pretty impressive. A few more. This one, yeah. So I mean, the idea, like your analogy of the foam core or the cardboard, that these components are pre-designed not just for manufacturing, but for the design process itself, is actually fairly rare in the sort of current building industry. It's something that we don't see because architects don't understand the manufacturing process. Contractors don't understand the manufacturing process. Manufacturers don't deal with assembly. They don't deal with design. So it's not just that we don't have vertical integration. We don't have a system that works within vertical integration. And so I think, you know, beyond, so not just the scalar aspect of the territory and the material science, what's really impressive here is the sort of disciplinary translations that you're doing. And maybe, you know, maybe talk a little bit more about that and how that process has evolved.
And it's the part that it's been the hardest to, thank you for that question, Ivan. It's the part that I'm most excited about is, you know, and as we've gone through and we've established capacity in the supply chain, you know, both at the mills and in now the mass timber factories. And I think people will be surprised when they understand the level of technology that's now integrated into North American mills and into CLT and glulam factories, that these ideas of parametric and performance-based design are just ripe to jump into. In fact, I think one of the biggest challenges I've experienced in my career as I've moved, back and forth between the public and private realms is getting beyond prescriptive design. That, well, we know 95% of our buildings are built in prescriptive manners, whether we're talking about code or engineering or so forth. And with some of my public hats, I'm involved in planning efforts, plan commission, and in state building code council, and these are the constant discussions we have, whether we're talking about energy, carbon, or structure, of trying to pair up prescriptive and performance-based design. And while we recognize that most buildings have to have that prescriptive approach, I think in terms of mass timber, it's really holding us back, because we are taking a prescriptive approach right now to whether it's the material, the lumber, the so forth, or how we very conservatively design in terms of strength and stiffness and so forth. So where I'm going with that is, once we choose to jump straight into performance-based design, which is more complex, and that's going to be our challenge across the disciplines, architecture, engineering. But I think there's a realization we can get 90% of the way there. We can take assemblies and solve 90% of the problem, meaning the finite element modeling, the analysis, the physical testing, it leads us to certifications, and then say, here are the parameters and the ranges that are flexible and that really play into now building information modeling, generative design, so forth, that would be hard to just start without having those other material scale, supply chain scale, aspects addressed and standardized.
That's also a good clarification. You would say that, in a sense, the step one was the supply chain, in a way, and understanding that so that you can be empowered to question certain standards, and then to sort of, we can think of the supply chain as a kind of context, but then it seems like the design and project delivery is another context that you're working within, almost another kind of supply chain, a human effort, intellectual supply chain, where we're also thinking about a sequence of events of different scales of communication even.
Yeah, it's a good point, because I remember back to my early days in my structural engineering career. We used to design steel braces. Maybe some people still do, a little detached from it these days. But you, as a structural engineer, you had to know how to detail out every single weld and the newest research and development on gusset plates and so forth. Because that was the Northridge area when we thought we knew something, and then it was completely thrown sideways. So I think CLT is that same. A lot of that, where I was going with that is, but now we're in this performance-based design, and the engineer and the architect will do the structural patterning, obviously do the dynamic analysis on the building, and then pass those requirements to a manufacturer of a buckling or strain brace manufacturer. So we can get to that same point with mass timber assemblies. You can still go detail out those welds if you really want to, or you can say that's really not the most important thing in the design of this building. It really is something that we can pass those performance-based requirements back down to the assembly level.
Todd, this is really interesting. I want to I think that was a good stream of discussion items on design for manufacture assembly, and also manufacturing for design. Could you go back to your, I think your second slide on supply chain? Ask a question.
Here?
It was a diagram about I think it was the second slide you showed. There we go.
Okay.
Yeah. Something that we talk a lot about in supply chain management theory is ultimately questions about value creation determine the supply chain path that one might choose, right? So every situation is going to be a little different, but if we look at, say, supply chain number 4, And in your experience, you know, and this is interesting for volumetric modular as it is for prefabricated enclosure panels, as it is for mass timber structural solutions, which is what we're looking at kind of here. You know, where in this supply chain, say for supply chain 4, harvesting, milling, panel pressing, subtractive manufacturing, additive manufacturing, systems integration, where would you say, or we could sort of discuss here on the call, would be the greatest value creation for the end of life product, which is the habitable building, right? For a developer or for society at large, where along that path is the greatest value created? And therefore, what you can start to track is where's the greatest potential enterprise, you know, and business opportunity in that supply chain along that path. So a lot of people have argued that CLT manufacturing, it's really interesting, but is there enough value created for the end product, you know, in all of this wood that's put into to justify that investment? So I just thought we'd unpack that a little bit and talk about value creation. And I guess that can be looked at in monetary terms, but what I'm not hitting is there's also societal implications and environmental implications and other things that would go into deciding where value really is created in a supply chain. So yeah, it's a complicated question. Yeah.
No, but I think it's dead on, Ryan, because, you know, we can talk about it in terms of mass timber and CLT. We could also have that same conversation with automated framing, right? Mm-hmm. As we get into whether we're going to stick frame something versus put it on a, you know, in a factory and panelize it. And I think so. I think there's two. Well, in my opinion, there are two answers there. One, the biggest cost driver that I think we've found is at that mill level. It's at that standardization that we really are limited if we are simply, and this might apply to light frame panelization too. If we're going to play directly into the sawn lumber markets, which is an open commodity market, and then put ourselves in direct competition with the Home Depots and the Lowe's of the world, that's a challenge, right? And I bring that up because and I've presented and lectured on this, you know, a couple of times. I think the North American engineered wood products, the mass timber, the CLT in particular, kind of industry has done itself a little bit of a disservice unintentionally by one, standardizing on lumber, but then also saying that we can use all the low quality stuff, you know, and so we can absorb what the home centers don't want, and in reality, that's not the case. You know, you're not going to find enough value at that level by taking the downgraded material, because as you know, in manufacturing, whether it's panels or panelization on light frame, you actually need, you know, high quality material, and that's what we learned from the Swedes and the Japanese and their manufacturing processes, that we really need quality and predictable material. So that's one point, but I really, if I were to put a number on it, the analysis that we've done over the years, I really think there's a 10 to 20% savings in cost. So that value by having that advanced milling, have that ability to do advanced scanning, grading, everything down to now the technologies of even scanning at the log level with CT and being able to do optimization that, you know, specifically for that. So that's one piece. But then the second piece is to capture the value. You know, the value add is really in, of course, that, you know, in that subtractive and additive manufacturing.
Right.
Again, a case by case basis. So, but that's dependent, right? That's dependent on whether or not that's the center of your world. Because what I've found in the bottom supply chain, which caught me by surprise, is that we have a big hurdle within our application of our architecture and engineering practices, being able to you know, adopt those the ultimate specification to something that is optimized somewhere further upstream.
And where do
That's
you
been
play?
one of the
Yeah, where do you place Mass Timber Systems, your new enterprise? You know, obviously we can see the history of what you've done at WSU and looking at harvesting, milling, supply chain, and then at Katerra with developing capacity really in panel pressing and subtractive manufacturing. And I'm sure they're looking at, of course, increasing their suite of integrated services there. What do you see Mass Timber Systems and what you're trying to do in that space, in this supply chain?
Yeah, so I think it is represented by the orange here. You know, the physical manifestation of that, if we want to call it that, is that secondary manufacturing. It is an actual facility that contributes, you know, off-site to that. And then whether or not it moves into on-site assist or simply coordination is another question. But then in each one of those orange arrows, being able to, once you center in that space, being able to now really drive those specifications both upstream and then make it more accessible downstream. And that can look like many things, of course, right? That can look like literally a catalog, or it can look like more robust integration into a partner firm's, you know, their catalog, which we know is digital. It's building information modeling. It's, you know, parametric scripts, so forth, like that, right? But they're really optimized in that orange box right here.
Mm-hmm. So it's additional CLT pressing capacity, but it's this additive manufacturing systems integration piece. So in that way, it's almost, if you look at more mature markets, as you've studied, you know, in Europe, it might be like in Germany or Austria, where you have the dumb panel producer, and that could be a portion of this, but then it's like the Kaufmans of the world that go and add value to those CLT systems to make them into sub-assemblies that can actually be delivered and installed on site. So that's kind of the value space you see yourself in, if I'm understanding.
It is, I hope, and it's, you know, but I think in that it's not just a, you know, consumer of the big dumb panels delivering the value add transformation, but hopefully in a public-private, you know, approach, being able to connect the metrics on the value chain. A great example is are we able to carry that carbon-related metadata to demonstrate that value? We have lots of third-party certifications, right? And we can put lots of different logos on our panels, but can we really create a more defensible, you know, transparency across that value chain? And meaning, you know, for example, in the state of Washington, I like to use this example of Department of Natural Resources, DNR, has done a great job over the last few years doing kind of GIS level prioritization. You know, that could be for wildfire danger, that can be for watershed, you know, habitat restoration, that can be for creating rural, you know, or supporting rural economies. And then in that kind of in the card, you know, layering exercise, which we all know so well now, but it is being able to have that traceability across there. And so whatever the end value system is, that you're able to pivot and make choices upstream towards that.
Yeah.
Sounds like also the appearance of MTS points to a further maturing of the standardization process that started with Katerra, in the sense that we can now imagine more, you know, we've already seen some convergence in terms of standards, and now we can see more players actually emerging out of Katerra, but also emerging in the marketplace in general, in the sense that now you can start to challenge other standards. Maybe also the idea of, like, something you've talked about a lot is using this kind of lens, this way of looking at the built environment to challenge things like even the way we grade lumber, the way, and the, you know, the 2x4 itself, which is a standard that has persisted, but in some ways, this lens, the supply chain lens, this product delivery lens that you and others have been developing, is actually the tool for both standardization as well as the tool to challenge standards. Can you maybe talk a little bit about that?
Yeah, and you know, a great example of that, Ivan, is something we learned on the Japanese trip. You know, for Modex. You know, we saw when a lot of steel manufacturing, of course, of modules, panelization and modular design, but also when they use wood, we see them buying either 2x6s from Canada or customized sizes at 30 millimeters. And so we see a lot of this as we've explored the supply chain in British Columbia, Washington, Idaho. A lot of Japanese grade material is being supplied from British Columbia, from the SPF mills and so forth. And then as we see it now and how they use it in their factories, we also saw value add in terms of gluing it up and then slicing it into 30 millimeter and 120 millimeter. And could you imagine, you know, proposing that in North America? You're creating a whole new engineered wood product that then goes into a different application, right? But clearly the value is there. So
yeah, we can see.
It's worthy of further exploration.
Yeah, because through the lens that you've been describing, we get Sweden and Japan have two different which are diametrically opposite, but are based on the same frame of looking, right? So Sweden is saying we have higher grade lumber that's naturally grown, and that's something we developed over 20 years, but the cost paid off. It produces a better quality product. Japan says the opposite, but not really, which is says, well, we don't want to develop a forestry sector like that, but we see the same economic value in having a particular grade of product, so we're going to engineer it, right? But the reason that they can do that is not because they don't know how much it's going to cost, is that in fact, it's exactly this kind of lens. It's a much more holistic approach to supply chain that allows those two leading, let's say, mature markets to make what seem like diametrically opposite decisions based on the same framework, right? It says, well, you know, and that's real cost. That's something, you know, going back to the broader discussion about offsite, what's been really helpful about the McKinsey report on productivity and problems in the construction industry is not so much that offsite is the solution, but that we have not really been able to account for the real cost of construction, conventional or otherwise, because one of the advantages of manufacturing mindset isn't speed, it's not necessarily cheapness, it's actually an understanding of real cost. It's really understanding a context, a framework, not because you care about the world, but because that's where actual cost is defined. And that's something that, you know, it's really fascinating to see, is that this is a different strategy than either Japan or there's a different ecology of developing in the US. I mean, this is starting to suggest that, but that framework is something that's been missing in the construction industry. That way of looking has been missing in the construction industry.
And so, Ivan, are you suggesting that when you say the real cost, it's something that Todd has been alluding to, which is real societal costs, real environmental costs, or are you saying real monetary costs as well, or how those things that I just mentioned are translated in terms of monetary terms?
Yeah, no, that's a great question, Ryan. But yeah, no, I think the first point is actually purely economic. I think again, McKinsey's not talking about, they should be, but they're not talking about the social cost of bad construction or the environmental cost. They're talking about the cost, they're talking about the economic impact of low productivity of a non-manufacturing mindset, right? So we assume that something actually costs, that a part of the construction process costs a certain amount, whereas in fact, what they've shown is that in fact, construction is more expensive than it ever was. Our argument for in the last 60 years and in fact, the 2x4 and lightweight construction has been a big part of it, is that while we may not be building well, while we may not be building ecologically, we are building cheaply. Well, it turns out we haven't been building cheaply. And that's what's so beautiful about the McKinsey report, is that it quantifies from a very neutral and kind of, let's say, Wall Street perspective, that we have been building low quality, but we have not been doing it cheaply. And it's, again, this manufacturing framework, which doesn't just mean using a factory, which doesn't mean using, a particular kinds of technology, but it's actually looking at real costs, real economic costs, which does also then translate into job creation, land management, different kinds of ways of looking at the supply chain, which then have social impacts. But primarily, we're not really even good at assessing the actual economic cost of construction. And that's what's so exciting about this new lens, which is not new. It's just, it's what makes, in manufacturing other kinds of products, it's not the factory space alone, it's this lens that makes them economical.
Yep, that's really good. Todd, I wanted to ask you a question about, in your experience, and hopefully you can talk about this, and I'm sure this is generalizable knowledge, but you know, where are the pain points currently? I know you're suggesting in the supply chain diagram we see on the screen that there are additional steps that really are not being taken right now by the market. We are just at the beginning of adding, you know, value by milling, pressing, and subtractive manufacturing, and then delivering to job sites to assemble these panels and elements. You're suggesting another step, which I think is much needed, and there's a big gap there certainly for MTS and others to fill. In the current process of delivering CLT as it's being done currently with, you know, a handful of factories in North America, particularly in the Pacific Northwest, where do you see are some pain points or some real bottlenecks and knowledge gaps that are causing problems? You know, what could be done to overcome those? You know, is it certain labor force are having trouble migrating? There's a certain knowledge base that's unknown that the construction industry needs to take up. That would be really valuable to hear about the labor and training and skills sort of area.
Yeah, no, that's great. And, you know, I can actually dial back a little bit. In 2014, if I can tell a little story here. So President Obama convened, I think it was 5 state delegations at the White House, and Washington was one of them, and with the goal of trying to advance mass timber. And so the Washington delegation came back, and we started a group in partnership with Katerra, a non-profit NGO in Seattle, with government agencies. So it was DNR, the governor's office, maybe a couple elected officials, Department of Commerce, and then the 2 research institutions, WSU and UW. And in that, and this is all public, you know, knowledge, and it's great to dig back, you know, to then the working groups that were set up, and they were focused on codes and standards, and they were focused on education of architects and engineers, and you know, and then supply chain for example, and then the 4th one was the 2-year and 4-year education piece, the technical development of advanced manufacturing, and often it's thought of as, you know, the CNC, right? Can we have that those Boeing-like academies that develop those 2-year trade skill sets that also then could lead into you know, development into a 4-year or beyond, you know, degree in architecture, engineering, or material science, or so forth. And it was really impressive how all the Washington institutions, the community colleges, and the 2 big universities coordinated, and really, you know, hey, we do this well, you do that well, and a plan was really put out. So that part, I actually have a lot of confidence. And then as seeing a factory come up and seeing, you know, very skilled millwrights and other, you know, on the floor factory team develop, most of them coming from different industries. You know, we have a large aluminum industry in Spokane and so forth. And that the transition was very quick and very impressive. In fact, I think it probably made it better that they came from other industries and brought those knowledge sets rather than organically growing it straight out of the 2- and 4-year schools. So I think it's both. But on the architecture and engineering side, I'm afraid the industry is still in a little bit of VHS versus beta mode, and a little bit of, you know, where maybe 20 years ago we were with SIP. You know, and if we wanted to do a building out of SIPs, you know, say .com boom 2000, we had 3 catalogs in front of us. I don't know if it's any different today, you know, and you had to pick one because there was a standardization, And if down the road, something went sour, you were kind of stuck, right? Unless you're gonna start over. And I'm afraid we're a little at that mode still. You still have to say, well, that manufacturer makes this grade and so forth, and this species, and I think we can get to within this box that we simplify the performance metrics and can push some of those other decisions, whether it's aesthetics or species or cost downstream, but we know we have a certain performance. And the same way we can lower the bar for the mills and so forth by saying, this is the mechanical grade of lamp stock that we're looking for. We will help you qualify into that, which is more of a European approach to lamp stock. So anyway, those are my current thoughts on those pinch points.
Yeah. Well, it's been interesting also to learn from Jennifer Cover at Woodworks that they have tried to go down a path of establishing more content and information for a new audience, not just architects and engineers who are designing and specifying mass timber buildings, but also construction managers who will be required to understand how to cost estimate, schedule, and ultimately work with the subtrades who will install all of these, whether it's a flat CLT panel, floor panel, or whether it's a systems integrated subassembly that comes to the site. It'll be interesting to see how not just the existing trades and the unions adapt to continued sophistication in offsite manufactured subassemblies, but also what will the universities and trade schools do to prepare their students for this brave new world. That's something Ivan and I are continuing to try to sort through. So we really appreciate the examples you shared actually of students who are doing this work, 5, 6, 7 years ago, and where they've taken their careers. And it's heartening to see a lot of schools moving in this direction. Ivan runs a really great research studio focused on modular that looks at supply chains in a very similar way you're talking about, Todd, and thinks about design for manufacturing assembly. And I think we'll see more and more schools of architecture, engineering, construction, and the subtrades move in that direction in the future. What was the reception from students when you taught that content back in the day, specifically architecture students?
Yeah, it's interesting because Ryan, we've got to know each other a little bit the last year or so, but when we were first starting this and working in other areas in biofuels, I of course come from a engineering and design background, and my focus wasn't really on small D design, design theory, design thinking, design, methodologies and pedagogy. And we started out by integrating across the traditional design disciplines, interior design, architecture, and landscape architecture, and really focusing on how students were learning. And, what we're really talking about here is, of course, divergence, convergence, iterative approaches until you can start to, converge into an acceptable level. That's acceptable design, a solution. And that's obviously very familiar to us in architecture. Obviously it's not so in engineering, and that's really, unfortunate that our engineering is often taught, or our practice is much more linear. There is a point A and a point B, and here's how you get there. There really isn't that opportunity to diverge and explore, multiple solutions and then keep improving. And so in 2014, Michael Wolcott, who's a professor at WSU, we set up an integrated design studio across those disciplines, and we probably ran 10 or 11 over a couple of years, and about half were mass timber, but others were related on biofuels or big environmental site, design, things like that could cross between civil engineering, structural, architecture, so forth. And I think what we found was a couple things that were really exciting. The architecture students were just really hungry for some of the technical aspect, but still be able to protect, their kind of creative freedom. Mm-hmm. What surprised us was that the engineering disciplines, when put in that space, they were a little uncomfortable, of course, in divergence, but their background in kind of coding and that kind of thought process made them just excel at these generative and parametric design. And it wasn't so much that we needed to teach them how to sketch, although we pushed that really hard. It was that they found that kind of iterative, approach within, Grasshopper and things like that are becoming more mainstream within the architectural discipline. So I put that out there because I really think that is one of the keys here to that orange box.
Oh, that's fascinating. And Ivan, you too. I mean, be interesting to hear lessons learned from your ModX studios that you've taught at Northeastern. Certainly you're teaching architecture students, but there's things they do well and things they struggle with because the culture of architectural education and the discipline may not allow that to happen. Maybe you want to talk a little bit about that. It'd be interesting.
Yeah, well, I think, and I've I learned a lot from Brian and also another colleague, Kyle Moe, at really thinking about, again, what we call this lens, where really, I think for me, it's been having them zoom out from the building scale into a kind of territory in the way that landscape architecture and landscape urbanism have related. I think there's a missing parallel in architecture, which is sort of the built environment architecture, where you really understand, just as landscape architecture start to understand processes at a larger scale. We haven't really done that. Well, we imagine more power, and students would love to have more power over a larger territory, but more responsibility over a larger territory is not something that architects seem to really care that much about. And yet, and the way to really sell that to students has been through the power of understanding how the 2x4 and the region are connected, and how it allows them at the end of the day to realize their quote unquote dreams, right? Because it gives them power, it gives them agency. That's been the way to sell, especially if it's students or even architects, honestly, professionals who have bought into a certain way of working, either through education or through professional experience. How do you then teach someone to care about things that they honestly haven't cared about, or they don't see their comfort zone in? And how you go from, how you really jump scales, as your diagrams suggest, is something that surprisingly is difficult at first, and then it becomes very empowering.
Mm-hmm. It's great to hear, because one thing we found is it always surprised us when we would do a GIS level network analysis, how do you connect a mill to here, and drive times, and how much carbon, what are the emissions, and so forth, right? And often we find, it would surprise us, it might be one of the architecture students that really excelled at that GIS level network analysis, where then we get down to the material scale and we start to break it down into, now it's not a structural pattern at the building scale, it's a material patterning. What if you think about CLT as printing with rectilinear, elements, or you take it down to nodes and you start to develop based on finite element modeling, and it's the same thought process, but you are scale jumping, obviously. And this was a USDA forest product research that we brought in a couple of students to really lead at the research level, and then you start to look at it both in terms of structural stresses, but also then the non-structural integration. What if there's this junction box that starts to become into that parametric scripting and so forth. So we really were able to touch and cater towards different strengths, all in this very familiar environment.
Oh, that's fascinating. Yeah.
So now, this is a really exciting time for you, Todd, and it's great to see the evolution from the pre-Katerra days, the Katerra situation, and now in the new adventure. And so where do you see the future of the orange box? Where do you want to be in 5 years or 10 years? What is it about changing standards? Is it about is it about advocacy? What's the dream scenario for you?
Yeah, it is kind of fun to talk about it now, because that orange box is not just a private effort, right? I am excited to get back into entrepreneurship. And what I've, always prided is that there's academic entrepreneurship you know, and, you know, kind of private entrepreneurship, startup culture, so forth, and really being able to balance between those two worlds. Because if we really look at it collectively, how do we get to the place where 5-10 years down the road, you know, whatever our goal might be, whether it's certain you know, interests would want to see more mass timber, for example, or you know, for me, it's really getting to that ability in the next 5 to 10 years to now go design. It feels like a certain investment for the last 10 years that's been engaging and exciting, but I haven't actually sat down with my, you know, my pencil and my Mayline and gotten back into that, you know, that design groove, right? So it's enabling that, but along the way, you know, bringing the appropriate things into the public realm so that we can accelerate this market diffusion, this acceleration, and so that part I'm as excited about getting in the lab and picking up some of that work, and then meanwhile commercializing it so that we keep that momentum going in the public realm.
Well, I think this has been a great conversation to understand your journey and your story, Todd, as it relates to the journey and story also of mass timber, as a you know, from forest to built assembly, and just to highlight that point, Todd did not mention, but he's very active and he's been on the planning commission in Spokane, and I think this is a good lesson for professionals, for Ivan and I, and for students. When you are trying to enact change, especially in an entrenched construction industry, one has to think about oneself as spanning across scales in an effective way, and having influence not only, you know, in the science and the engineering aspects, but also in the political and social aspects of the delivery of systems in construction. So with that, I want to thank Todd for coming, and any closing comments, Ivan, Todd? Nope. Thank you so much for coming, and we'll talk soon. Thanks.
No,
Thanks.
thank you so much.